Welcome to section 6.1. In chapter 6, we're going to be looking at solving something called systems. And the first way we're going to solve these systems is by graphing. So let's review graphing. I want you to graph each of these equations. Y equals 2x minus 3, 3x plus 2y equals 6, y equals negative 4x minus 1, and 2x minus 5y equals 10. We're going to graph each of those equations and see how you do. Okay, our first equation is in slope-intercept form. We graph the negative 3 first. That's the y-intercept. So we come down to negative 3. From there, our slope is 2. So that means up 2 and over 1, and that gives us our purple line. The second graph is in standard form, or the second equation is in standard form. So we cover up the 3x, so our y is going to be 3 because 2 times 3 gives me 6. Cover up the y, and 3 times 2 gives me 6, so my x is 2. I put a dot on 3. A dot on 2, and I connect to get my blue line. My green line, I come down here to negative 1 and put a dot. From there, I go down 4 and over 1 and get my second green dot to give me my green line. And last, I have another standard form. Covering up the x, I get negative 5 times negative 2 would give me a positive 10, and 2 times positive 5 would give me 10. So dot on negative 2, dot on 5, and connect. So that's our review for graphing. We're going to need that today because, again, we're going to be solving what's called systems by using graphing. So what is a system? Well, a system of linear equations has two or more linear equations, and a solution to this system is an ordered pair that makes all of the equations true. So, what does it mean to have a solution to a linear equation? Well, in order to be a solution, it has to be a point on that line. So, solutions to linear equations are any ordered pairs, x, y, that make the equation true and that are exactly on the line. So, for example, here we have y equals 2x minus 2. All of these would be solutions to our equation because all of these are points on the line. Are these the only points? No, there's an infinite number of points that are solutions to this particular equation. Any single linear equation has an infinite number of solutions since the line goes on forever. There are an infinite number of points on the line. So again, the solution to a system of linear equation is any ordered pair that makes both equations within the system true. The point where the lines cross is the solution to that particular system of equations. So we have three possibilities for the amount of solutions that a system could have. We can have one solution, we could have zero solution, or we could have an infinite number of solutions. One solution would look something like this. You would graph your two lines and they intersect here at one point. That would mean you'd have one solution. No solution would look like this. These two lines are never going to cross. So therefore, there's no solutions. They're parallel lines. They have no crossing point. An infinite number of solutions would be when you have two lines that are on top of each other. They're identical. That means every single point that's on both of these lines would be a solution to our problem. So there's going to be an infinite number of solutions. So let's take a look here and see if we can figure out how many solutions we'd have. Which one has one solution? The last one. Very good. Which one has no solutions? The middle one. Excellent. And which one has many solutions? The first one. Excellent. Again, let's take a look here. This one would have one solution. There are some other things that we should know about this. They are called coinciding lines. It's consistent and dependent. There's some other vocabulary that goes along with these. These are parallel lines. They are inconsistent and independent. And the last ones, this has one intersection, it's consistent, and it's independent. We're going to focus just on how many solutions that we have, but these are some vocabulary words that you should be familiar with. So, in order to solve a system by graphing, we have three steps. First step is to graph each equation. Second step is to determine the number of solutions, and the third step is to calculate your answer. The goal is to identify what the exact crossing point is and label it as an ordered pair. So the solution to a system of two linear equations may be interpreted graphically as a point of intersection between the two lines. So notice here in our example that our lines intersect at the point -2, -4. So that's our solution to this particular system. Let's try an example of our own. We're going to graph the two equations, y equals 2x plus 4 and y equals x plus 2. Then we're going to figure out which of these is a solution. Then we're going to check to make sure that that is actually the solution. So I went ahead and graphed. I have my two equations here. I came up to 4 for my y-intercept, up 2 and over 1, and connected the dots. I came up to 2, I went up 1 and over 1 because my slope is 1, and connected. Now here's the thing. The problem with graphing is, notice my dot here is not exactly on any of these 4 possibilities. It's closest to this one here, so I assume that that would be the correct answer. But when I check it, I put the 0 in for y and the -2 in for x. I can clearly see that this is a true statement. 0 does equal 0. Same thing over here. When I put in the 0 and the -2, I come up with a true statement. So my solution to the system is -2, 0. But again, on my graph, I could interpret this as -2, I don't know, maybe half, something like that. So the problem with graphing is, did everybody get the exact same answer? I had grid paper here. I had straight lines here. If you're just using blank paper that you made your own grid on, you're not using a ruler, you're probably not going to get the same answer as everybody else. That's the problem with solving systems by graphing. They're not very accurate. Even if you use a ruler and graph paper, it's still quite possibly not going to be the exact answer. Using a graphing calculator, however, will get you the exact answer. So we're going to take a look at that. To solve the system, y equals -2x plus 9, excuse me, and y equals 3x minus 4, we type the two equations into our calculator. We're going to put the first equation in y1, the second equation in y2, and we're going to press graph. Then we're going to use the intersect option to find where the two graphs intersect. We're going to press second, trace, and number 5 for intersect. We're going to move the cursor, which they're calling a spider here, close to the intersection and hit enter 3 times. So the answer to this system would be 2.6 and 3.8. Again, if we were graphing this, we probably would not have come up with these specific answers. Let's try another one. We have x minus 2y equals 14 and x plus 3y equals 9. Again, when we do stuff on the graphing calculator, it's only going to take answers that start with y equals. So we've got to do some work here and get these into slope-intercept form. Once we do that, we get y equals x over 2 minus 7 and y equals negative x over 3 plus 3. We're going to type those two equations into our calculator, and then we're going to press graph. We're going to change our viewing window because, again, as you notice here in this picture, we can't see the intersection point. So we change the window, and now we see where our two equations intersect. So to use the intersect option to find where they intersect, we do second, trace, and the number 5. And then again, you move the spider close to the intersection and hit enter 3 times. Your answer is x equals 12 and y equals a negative 1. Let's try another one. Go ahead and graph these two equations and we'll see how you do with your answer. So let's see. If we take a look at our graph, again, they're already in slope-intercept form. So when we graph these two, this is the graph that we should come up with. And you see that these two intersect down here at 3, -4. One more example, go ahead and graph these two and let's see what we come up with for an intersection point. So our intersection point is here. Now again, since they didn't give me a specific grid, it looks like a little less than 2 and a little more than 2. So 2 point something and 1 point something? I don't know.